Nobody's here. Where are you guys? There was a bunch of. Ah, all right. So when you get here, go ahead and do a roll call. Sign in. There we go. So we got Demo. We got Mariana. So yeah, sorry about that, guys. I don't know what was going on with that. Just well, I this user error. I had another window open where I was streaming the I had the live stream playing, and then my microphone was picking up the playback, and then it started to loop and getting all kinds of crazy stuff, and yeah. All right, so George is here. So I hope everything's going well with all you guys. Hope things aren't too crazy back there at the ranch at home. Hey Martin, how's things? And yeah, hope everything's going okay. So here's what we're gonna do in this video. What we're gonna be doing today is we're gonna be talking about functions. We're gonna start. Hey Vanya, we're gonna be hey with two Y's even. We're gonna be we're gonna be talking about functions, what they are, how the notation works, all the way up through inverse functions and all that kind of stuff. Chris is here. Crespo's here. Man, this is like a reunion. This is fantastic and wonderful, right? Yeah, Johnny, I hope things are good. You're not fighting with your mom, are you? Okay. And then, boy. Hey, Danitza. Danitza, I have a question for you in particular. Hi, Leah. Danitza, do you know what this is? Do you know what this is, Danitza? You weren't here in the live stream yesterday, and I thought you might have known. But, a freshman student emailed me at like around 4:30 this morning, and they knew what it was. So they got the prize, which isn't this, because this is way too valuable. And it wasn't this either, because this is also way too valuable. Oh, wow. So Johnny says that stealing car is a word. Now, Johnny says that he doesn't fight with his mother because his mother loves him. Well, that's probably true, but that doesn't mean you don't fight, right? Now, this is not a stealing cars award. I just want to know if Danitza knows what this is. Or anybody else does, and that would be good too. Well, I'll show you at the end of the video. If somebody gets it first, then maybe they will get the award. Maybe the award will be this. I mean, come on, this is hard to come by right now. Or maybe it'll be one of these. If and when we come back. Danitza knows. She says it's something from the movie or the TV show The Office. You are absolutely correct, Danitza. They had a silly award thing for their Office awards called the Dundies. And so my daughter had this made for me a few years ago for Christmas, 2 years ago, maybe 3. Yeah. So anyway. Wow, Mariana casting shade. She says that I got better merch than Crespo. No, Come Up Kids, legit. Not sure about that. All right. So, Johnny says he's here, HEAR, to learn math. Not English, though, math. All right. That's right. So, let's get to it. I'm going to go ahead and switch over to the document camera. Oh, maybe. Hold on. Let me see. Document camera. No. Got it. All right. So I had to reset some things when I had that last little snafu. So, wow. I think you misspelled her name there, Demo. All right. So anyway, here's what we're going to be talking about. We're going to be talking about all of this fancy function stuff, right? And so we're going to do, I know for sure we're going to do like 6 kind of mini things. We're going to talk about what a function is. So we're going to define functions. So just in case you forgot. So we're going to define a function. You guys remember what a function is? Anybody remember? Johnny, you really need to go to school. Oh yeah. So what a function is it's a mapping, which means like a relationship connected, right? A mapping or pairing of an input to exactly one output. Yeah, that's like the basic definition, right? So an input to exactly one output. So, for example, if we let's do a couple of ways we can see functions. Like you could have input and you could have output, and you could do like a chart like this: 3, 7, 4, 9. So those could be your inputs, and your outputs could be 1, 3, 6, 4. Yeah. So this would be a function. So 3 goes to 1, 7 goes to 1, 4 goes to 6, and 9 goes to 3. That is a function. Absolutely, it is a function because each input has only one output. It's okay that 7 and 3 share the same output. That's okay because this input has one output. This input has one output. Now, where it would not be a function is if we had like 7 having 2 outputs. Now it's no longer a function, do you see? There's another way that you might be asked to determine if something's a function. And both of these examples are going to be things you're going to see, like you could see in a different kind of setting beyond Cambridge, so like a United States sort of class. Yeah. Oh, Ruben's upset. It said it didn't give him a notification it was on. Oh yeah, Jose. Yeah, you can watch this absolutely. This is actually a review for you guys as well. So yeah, welcome. Join us. All right. So another way you could see a function is if you had like something like this. So if you could draw a vertical line, like these are vertical lines. If your vertical line only touches the graph at one point, anywhere on the graph, on every single spot on the graph, then it is a function. So this is a function. But like for example, this would not be a function. It's a graph, but it's not a function because you see, x is the input and y is the output. And here, like right here, for example, where x equals 0, do you see we have 3 outputs? So we have an input of 0, and we have output. We have 3 of them. So we have, like, say that's -1, and let's say that's 1, and let's say that's 5. So if we did like an input-output chart, we would have 0 with 3 outputs. So definitely not a function. So Vanya wants to know, are quadratics functions? Actually, quadratics are functions. All right, so Vanya, this format is the best we got since we can't meet face to face. And one of the things that's kind of strange, hey Manny, one of the things that's kind of strange is that there's a little bit of a delay. It's about 30 seconds between what I'm saying right now and you hearing it. And so by the time you ask me a question, I've already moved on. But I try to look up every few seconds to see if there are any questions in the chat window, and then I'm very happy to go back and answer them. So for those of you who this is your first time seeing one live, if you have a question and you move on, I will come back to answer your question, and I think it's a really good idea that you do ask the questions because I want to know what they are anyway. So let me show you why a quadratic is a function. 2 reasons why. Ready? So let's take a look at a quadratic. Let's take a look at a simple one, like x squared. Is there any number that you could put in for x that you would square it and you would get 2 answers? So like if you put in 0, you get 0. You put in 1, you get 1. You put in 2, you get out 4, right? So this is your in and this is the out, right? And any number you think of when you square it, you just get 1 answer. You don't get 2. Square roots you get 2, but not for squares. And parabolas, they look kind of like this, right? And one of the things that people misunderstand is they think these sides are parallel, but they're not. They're not even lines. They're not straight. They're curved everywhere. And they do get farther and farther apart, and they start getting more and more vertical, but they're never, ever, ever vertical. If you were to zoom in, like if you were to use Desmos and you were able to zoom in really close, you would see that it's not a straight line. It's actually curved. Does that make sense? Hey, Carla, how's things? Let's see. I thought that it was a function was like a formula. A function can be a formula, Johnny, but what a function is it's a pair of an input to an output. So it doesn't even always have to be from like an equation, if that makes sense. So, yeah, formulas can be a function. Not all formulas are functions. Functions can be formulas, but not always. And Yeah. So what a function is it's an input to exactly one output. So Vanya wants to know, but can you put, let's say, 2 and negative 2? Ah. So Vanya's question is, and it's a very good observation. She's like, well, let's say for this function right here, we put in 2. We would have 2 squared, which is 4, right? So we have an input of 2, output of 4. And when you put in negative 2, you also get out 4. That's true. So what this is, though, this input only has one output. This input only has one output. It's okay that they share the same exact output. But, yeah. Let's see. So I'm reading what you guys are saying right here. Yeah, so 2 inputs, or even more than 2 inputs, can share the same exact output. In fact, you can have a function like this. This f of x equals, say, 7. F of x equals 7 would be just a, so let's say that's 7 right there. It would be a horizontal line right there. That is perfectly fine. That is a function. F of x equals 7 is a function because each input, no matter what number you put in, you always get a 7 out. But you never can find a number you can put in a number that would give you 2 outputs, because no matter what you plug in, you always get out a 7, which is just a single output. Now, there's a thing called 1-to-1, which we might be able to go over here soon. That's something new. 1-to-1 functions. Quadratics are not 1-to-1. This is not 1-to-1. And so the inverse of quadratics are not functions themselves. But, yeah. All right, so Johnny says, so Vanya's got that. Johnny says, what if you get the output? How do you find the input? Well, it would depend on the function. So like if you had f of x equals x squared, and you knew that f of x was equal to 16, you would just have to figure out what number is equal to 16. So here, x would be 4, because 4 squared is 16. Yeah. Yeah, that's right. Exactly. So Vanya says you'd kind of have to like set up an equation and solve it. That's right. All right, so those are good questions. Are you guys good to go with what a function is and what a function is not right now? I'm going to try to use Desmos here. Demos. No, yeah, Desmos, not demo. Right. I'm going to try to use Desmos here. Right? On my phone, and I dropped my phone. Look at that. Oh, that is sad right there. I dropped it over spring break, and it hit a rock just so. But that's okay. So, what I wanted to do is I wanted to show you guys what y equals x squared looks like, which you guys already know, I know. And so when you look at, I'm going to put it on the document camera. When you look at y equals x squared, they're starting to look horizontal over here. I mean vertical over here, these sides. You see, and if you scroll down, they do kind of look vertical. Like especially if you zoom way out, they start to look really, really vertical. Looks like they're going straight up, right? So all I'm doing is I'm kind of zooming out and scrolling down. So here they almost look vertical, but if you look at the whole entire screen, you can see the distance between the curve and this line, whatever that number is, it is getting smaller. The distance is getting smaller. This curve is approaching this line, and if we go up high enough, it's going to cross it and go on the other side. So you see, it's still getting wider and wider. They're both getting wider and wider, and they're not going straight. They are curved. If we zoom in enough, we might be able to see that they are curved. Let's see. Man, this is kind of crazy. This is a really powerful app. It does some really amazing things, and it's cool that it's just free. So there we zoomed in so much it almost looks parallel, but you can see, maybe you can see, I can see here, you might not have enough resolution, that down here, the red line, the curve, is on the left of this vertical line, and up here, it's on the right. So it's curved, it's crossing it. So anyway, I don't know if that helps you see it or not, but yeah. All right, so let me see. I'm going to go back to the chat room right here. Demo saying, let's say you have a chart. You need to find... Oh, yeah. Okay, so you guys are helping our buddy Crespo out there. That's good. I got it. All right. Let's go ahead and Hey, Mr. Estrada, how's things? Man, you've missed out. We already had an awards ceremony. Students were guessing what this was. Do you know? Do you know what this is, Mr. Estrada? Because the award that you would have won. Oh my goodness. Anyway, yeah, we're just going over some review stuff for these wonderful people, but feel free to hang out as much as you want. It's kind of fun. Not nearly as good as real class, but yeah, we're doing okay. So we're gonna move on now to domain and range. Now I'll switch the camera over right now to the document camera. Here we go. Going well. Good, good. Oh, you did see it. Okay, okay. Yeah, it is from The Office. That's right. And my daughter made it for me. It's a few years ago she made this Best Beard Award. You cheated. I know. All right. Well, you were honest in saying you cheated, so maybe you'll get the award anyway. All right. So here's what we're going to do. We're going to talk about domain and range of functions, right? So first of all, you guys probably already know this, and if we were in a classroom, I'd certainly have you guys tell me. So just take a minute and think. Do you know the definition of range, and do you know the definition of domain? Hey, Angela, it's good to see you here. How's things today? Where's your buddy Dida? Is she awake yet? All right, so domain, in case you don't know, is... Oh, Angela's not that tardy, Mariana. Domain is the set of all possible inputs. And inputs are, of course, the x's, as in f of x. Yeah? And that's really a confusing concept at first because almost everything we deal with has any number you want that you can put in for x. Like, the one we were just talking about, say f of x equals x squared. Well, the domain is going to be all real numbers. Right? So, almost always the case. But there are some things, like, for example, if you were going to say f of x equals 5x over x minus 2. Well, you know how you can't divide by 0. You can't cut something up into 0 parts. So here, the domain is anything except for 2. And the reason why is if you have x equals 2, if you put in 2, you're going to have 5 times 2, which is 10. That's not a problem. But 2 minus 2 is 0. 10 over 0. This is asking, remember, this is asking 0 times what number equals 10? There is no number times 0 equals 10. This is why there's no number. It's not a number. That's why we call it undefined. So those are the kind of situations that you can have where... those are the kinds of situations you can have where you have a limit in the domain. And that is something that maybe we'll have some time to really dig into a little bit later because it's not something we talked about a whole lot here in Cambridge, but it is going to come up when you move forward into pre-calc and calculus. So there were two things I wanted to put on my list. One-to-one functions, because we didn't talk about those, and you're going to learn those in pre-calc, and we might have some time to do that. And the other one I wanted to talk to you guys about was this right here, and that was finding domain. So here's my list of homework of things to prepare for you guys. But if I forget, you're going to have to remind me. But hopefully I'll keep my post-it note right there. All right. Now, reading the questions right here. Oh, I see. You guys are kind of helping each other out there. So I think you guys are all good. All right. So any questions on domain before we move on? Domain is a set of all possible x coordinates or inputs to a function. It almost always works. The only time it wouldn't work is one of the times it wouldn't work is if you had if you had a 0 in the denominator. There's one other time that's kind of easy to see where you would have a limit in your domain, or a missing value, I should say. Let's say we had something like this. Let's say it was x squared equals the square root of x. Can you guys think of what the domain would be for that? X squared. Sorry, f of x equals the square root of x. F of x equals the square root of x. So here, like you could put 0 in. F of 0 is easy. That's equal to 0. F of 4, well, that's equal to both 2 and -2, right? Because the square root of 4 has 2 answers. But what about -4? What's the square root of -4? Well, it's actually going to be plus or minus 2i. And that's another thing that maybe we'll have some chance to talk about in this format is imaginary numbers. So, because, you're right, Vanya, it's going to be actually it's going to be anything greater than 0. Mr. Estrada busting chops today, yelling at Angela. Angela deserves it anyway. That's not true. Angela's all right. So you're right, Vanya. It's going to be all 0 is not positive or negative. It's going to be all numbers greater than 0. So the domain for this would be, the way I would write it with what we know how to write right now is x is greater than or equal to 0. So that's what we would say for that one, right? 2i. So yeah, Johnny, you don't know what 2i is yet. It means it's a set of numbers you don't know about yet. And maybe we'll have some time to talk about it here in the near future because, well, not because maybe I'll remember because I got it on my list. That's right, demo. It's imaginary, which is a well, it's a confusing name. It's a confusing word. All right. So, are we good on domain? If not, just leave me a comment in the stream right there and we'll come back and answer your question. In the meantime, I think it's time to move on to range. So, let's do range now. Ready? Range is really similar to domain. Range is the set of all possible outputs. And this one we're more familiar with. We're more familiar with this because, like, for example, if you had x squared, or f of x equals x squared minus 4. Well, you guys had learned that the y-coordinate of the vertex is either going to be the minimum or the maximum output. So this y equals x squared minus 4, it would look kind of like this, right? This coordinate would be 0, -4. And nothing goes below it. The vertex is either the smallest or the biggest point. If A is positive, then the vertex is the minimum. And if A is negative, the vertex is the maximum. So here, the range is going to be from -4 to, running out of room, positive infinity. And we've done quite a bit of those. So I think we're okay. Vanya wants to know, are we going to go over the functions quiz today or tomorrow? Well, I think we're going to go over it tomorrow morning. That's because that way we kind of get back on track with introducing new stuff in the afternoon and in the morning reviewing old stuff. Because right now we're kind of backwards of how I think it's going to work out best. So Vanya, tomorrow we're going to go over the functions quiz. So today we're going to kind of review the information, and then tomorrow we'll answer questions you guys are having. Make sense? So any questions on range? We got domain, which is kind of new, kind of confusing and tricky, not something you guys are super familiar with. And then we've got range, which is something that I think you guys are all right with. Thank you, Mr. Estrada. Hope you have a great day. Hope you're not going too stir crazy. Hope they keep you busy, right? Yeah, Johnny, there's a quiz. It's in the, I think I put it in the assignment box in your Cambridge 2. So let's see, in the classwork box. Let me find out. Functions quiz. Ooh, did I? Yes, I did. It says due today. It's in there. And you can click on it, and there is, oh, I see. Hold on. Let me go ahead and see if I can edit this, Johnny. So while I got you guys right here, let me see if I can edit this and go ahead and upload a link. because this thing's being kind of... All right, so let's see here. Let me add the file. Maybe I put it in the classroom stream. So one of the issues I'm having is I can't go through and delete all of the assignments very effectively, and I need to grab some time when I can go do that. You'd think I'd have nothing but time because we're teaching, we're at home, but the truth of it is it's been kind of hectic and busy. So here's what I'll do. I know I put it in the classroom stream because I did so yesterday, but I'll go ahead and add it as an assignment so it'll show up there for you today. And there we go, functions checkup. So it should be there for you right now, Johnny, okay? So it'll be in the assignments thing. Dida, of course. So yeah, Alicia, for today, and do tomorrow, we're gonna do the quiz on functions. So just like before, you don't need to turn it in. You can just mark it as turned in, but just do it on your own. And then tomorrow we'll grade it together. Okay. You should. So demo says you should send a link to the test we finished in the classroom. Let me do that right now, Demo, because I don't want to forget. Demo wants me to send the link to the live stream we did where we were... I'm looking and talking at the same time. Apparently I can't do that. So when we went over the algebraic fractions quiz in a live stream, all that gets saved, and so Demo was asking for that. So algebraic fractions, factoring view review with algebraic fractions, no. Here. Let me find it for you, Demo. Got it. So let me copy this link for you, and I will place that in Google Classroom right now. So, in fact, hold on, let me see. Huh. Close, not close. That's right. Okay, so I'll just put the link, Demo, for the video where we did the grading of the algebraic fractions in the stream. Hold on, let me title it for you guys. So this is so you guys can send me an email, or in Google Classroom you can tell me how you did, and you can ask me any questions you guys might have, all that kind of stuff. Yeah, he is. Johnny, he's going off. Your phone won't let you do the quizzes. So the quizzes, I don't know why this happened, Nida. When we were in school and I scheduled everything ahead of time in Google Classroom so that, you guys would have notifications and a calendar of all the stuff we're going to do. When I did that, for some reason, Google decided to add some Google form to each one, but the Google form doesn't actually exist. It's blank. There's nothing there, but it still shows up. So the reason you can't download it is because there's nothing there. But I uploaded the Word document file there just now, so you should be able to get that, okay? And if you can't, just send me an email it to you, and then you guys will have it. All right. Let's get back on track here, shall we? We got domain, we got range. Let's talk about types of functions now. Okay, types of functions. You guys ready? Types of functions. Types of functions. So one of the things that's going to happen is you might be given a graph and you might be asked, hey, is this a function, yes or no? And to do that, to answer that first question, is you're going to do, if you have a graph and you're asked if it's a function, yes or no, you're going to do the vertical line test. You're going to see if you can just draw a vertical line through the graph, and if it crosses the curve more than once, not a function, right? But after that, they're going to ask you, what kind of function is it? So the ones we have to learn are linear, quadratic, cubic, and the one that's actually super relevant today, exponential. I made a video about exponential growth and what it has to do with the current coronavirus, COVID-19 stuff. I don't know if you guys saw it or not. It's kind of crazy though, because I don't know. It's so I don't know, the spread of not just diseases but growth of populations and things are exponential, and they so closely match just the basic curves that we know about, um, that it allows us to really understand what's happening in real time just because of the math. So yeah, so it's kind of interesting. So if you guys didn't see that, and you're interested in it, and it might help you to understand how this disease is and this virus is spreading, and why people are like shutting everything down and all that kind of stuff. So it's not alarmist or anything, it's just there. So anyway, linear. So linear has a constant slope, right? And in an equation it has a constant slope, and slope is also change, right? So in a graph, it's linear is going to be a straight line, and if it was written as an equation, it would look like this, right? And yeah, that's what they look like. So if you were given like an input-output table, like this, 3, 4, 5, 6, 7. So here, let me write this down, and then I'll explain to you what I mean. So one of the things that dogs are going to go crazy. I think the propane delivery truck is here. Oh man, it's going to get nuts. All right, so here's one of the things that's going to happen. They're going to give you one of these three things. They're going to give you an equation like y equals 1/2 x minus 7. They're going to give you a table of values, or they're going to give you a graph. And they're going to say, hey, what kind of function is it? Is it a function, yes or no? And if so, what kind of function is it? So yeah, if it's a line, it's linear, right? If it's in slope-intercept form, or if the biggest exponent, the degree, the biggest exponent is 1, it's linear. Or if it has a constant change, like a slope, like here. See the difference between that and that is 3, and here is 3, and here and here and here and here. Between all of them, the difference is just 3 all the way across. That's linear, right? So you guys are really familiar with those. You guys are also pretty familiar with quadratics. Quadratics do not have a constant slope. And you guys definitely know what the graphs look like. You know, they're parabolas, right? So you guys are good there. In a function, like as written as an equation, you get a couple ways you might see it. You might see it in vertex form, or you might see it in standard form. I'm pretty confident that you guys are good with all that. The table can be kind of strange though. So you might be given an input-output chart like this, right? Hold on, Johnny, I'll get to your question right now. You might be given an input-output chart like this, in, out. I'm going to do one I can figure out the numbers in my head really easy, so let's do 2, 3, 4, 5, and 6 again, right? So here we got our input-output chart, 4, 9, 16, 25, and 36. You see, this is just x squared, right? But when you look at the change, look at the difference between these two is 5. And then 7, and then 9, and then 11. You see, the first change is not constant. This right here is called the first change. Here, the first change was 3 everywhere. The first change was constant. It's linear. Here, the first change is not constant, so it's not linear. That doesn't mean necessarily that it's quadratic, because if the first one's not constant, then you got to go ahead and take a look at the rest. 2, 2, and 2. You see, that's called the second change. If the second change is constant, it's quadratic. That's how you can tell. All right. Can I say the numbers in the output section? Do you mean you can't read them, Johnny? Like 4, 9, 16, 25, and 36. Yeah. All right. I guess the dogs have calmed down. So I guess that the propane truck's not here after all yet. All right. Let's move on to cubic, because cubic is new-ish. You've done some stuff where you did some inputs and outputs, but and graphed some of these on some quizzes, but nothing too big. Vanya wants to know. Why is the first change being constant relevant to anything? Because here I'll show you. This first change is the slope. So this equation right here would be 3x plus 5. That would be, this equation right here would be 3x plus 5. Sorry, Johnny, I'll write a little larger, okay? This equation right here, Vanya, would be 3x plus 5. But sometimes coming up with the equation, with what the equation is really, really difficult. If you had this, you'd be like, yeah, that's linear, no problem. But you can tell also if it's linear because the difference between consecutive outputs, that is the slope. The slope is 3, and it's 3 always. It's constant. So that's how I know it's linear. Does that make sense? Yeah, you're right, Ruben. Yeah, okay. And so like here, there's not a constant slope. It's curved. It's curved everywhere. So the second change is constant, and when that happens, it's quadratic. And you guys, I don't know if you remember, but for cubics, it's going to be the third change. Now for cubics, if you have a graph, it's going to look something like this. It could be flipped over. It could look like this. It could go down instead of up as well, right? So cubics are going to look like that. And the degree for a cubic, the biggest exponent, is going to be a 3. Do you see? So for a cubic, the biggest exponent is going to be a 3. And let's go ahead and take a look at the input and the output chart. Let's see. Yes, that's right, Johnny. So if it's got the same change in the same pattern, like over here, then it's linear. So Johnny was asking about this first change being the same. That means it's linear. Yeah. If the second change is constant, then it's going to be quadratic. And if the third one is, it's going to be, if the third change is constant, then it's going to be cubic. So I'll try to write this one a little larger for us, Johnny. There we go. I bet Dida could see that with her glasses off. Sorry, Dida. I can't see either. I need glasses. So, here, check this out. The equation is, so Demo's asking what would the equation be, because for linear it's y equals mx plus b. We got two forms for quadratic. So for cubic, it's a little bit different. All you're going to look for is an x cubed. If you have an x cubed and the cube is the biggest exponent, then you're good to go. So you don't need to worry about the forms or anything like that. Yeah. And degree is the largest exponent, essentially. For polynomial equations, the degree is going to be the largest exponent. That make sense? Yeah. Yeah, I know you can see. It's Johnny that can't see. I know. Sorry, Dida. You'll have to forgive me. Maybe I'll give you the toilet paper. Okay, so check this out. Well, let's just do this one right here. Let's do 8, 27, 64, 125, and 216. So this would just be x cubed, right? But let's say you didn't know that. You didn't recognize it right off the bat. You were given this and you were asked, hey, is this a function? It is, because these are the inputs. Each of these inputs only has one output, so it is a function. It's definitely not linear, because look, the difference between those two right there, I think that's 19, right? 19 plus 8 is 27. Oh, man, I'm going to bust out my calculator here for the rest because, oh, this is sad right here. All right, because I'm not really sure. So 27 minus 64, well, 64 minus 27 is 37. And then 125 minus 64, 61, and then 216. I should know these numbers, but I'm kind of tired. All right, there we go. That's a 91. Definitely, definitely not linear, right? Adiana wants to know, can I have the roll of toilet paper? You were the first one here. Oh, that's what she says. She thinks first person deserves the toilet paper. Cubic does kind of look like a tangent graph on the side. You're right, Dida. All right. So first change, not the same. Second change, oops. Let's do 37 minus 19, right, it's 18. And then 61 minus 37 is going to be 24. Hey, look at these. They're going up by 6 every time. And the next one's 30, you see? And then the difference between those is 6. Ah, so check this out. Um, the next the next one right here is going to be 36, and then 91 plus 36 is going to be 127. So 216 plus 127 equals 343, and oh, that's funny because I was thinking about the number 7. 7 cubed 343. Do you guys see how I used this pattern to figure out what the next number was? That's kind of cool, right? Yeah. All right. So anyway, the thing I want you to learn here is that cubic, first change not the same, second change not the same, third change the same is cubic. Yeah. All right. Now, exponential stuff. It's kind of strange. Here, let me bust out the Desmos again right here. Wait, hold on. Let me bust out the Desmos. I'm gonna go ahead and close it, and then I'll reopen it. All right, so here's Desmos again, and we're gonna do an exponential function. I want you guys to see what they look like. So let's do exponential functions are like 2 with an exponent. Oh man, I don't know if actually I know I could do it on here. Let me see. Nope, not there. 2. I'm not sure how to do the to the power of, and my silly thing here is busted. So I know I could do it on the graphing calculator, but you guys aren't used to a graphing calculator. So 2, nope. Yeah. Because we got to do 2 to the power of x. Now we don't want statistics. Miscellaneous. Here we go. Maybe. No, that's all. Well, nah, that one won't work. There, duh. Man, I knew there was a way. I'm sorry. Sorry that took so long, guys. Thanks for your patience. Look at this graph. What I want to do, I want to change some of the, I want to change the y-axis from, say, let's say, -1 to 400. Okay. No, that's not right. Let's do -1. Let's do -1 to 15. Let's see if that looks good. No, it's still, the scale's kind of strange. Let me try one more thing right here. Sorry about this. So let's say from -10 to 5. There we go. So here we have an exponential curve. So let's talk about these really quick. Let's see. Martin says he needs the TP. Oh man, are you guys really out, Martin? And then let's see. Demo is saying he's misspelling Dida's name, and then I think she low key. Okay, onto something. Cubics look like a tangent graph. That's true, they do, but they're actually curved everywhere, and tangents are straight lines. Um, and then, quick, name 3 things you use every day. Oh, exponential is not degree 4. Exponential, Johnny, is actually. So here's what exponential is. Exponential is like this. Exponential is like f of x equals 2 to the power of x. That's an example of an exponential graph, and this is what they look like. There's no constant change. There's no slope. So if you see like a base that's a number, like say 5, and you have an exponent that has a variable in it, that is going to be exponential. And the graphs look like this. And this is how, I don't know if you guys saw some of those graphs that have been showing the growth of the coronavirus, but they look just like this. And so here's the thing. They have this one has like one x-intercept. And as you zoom in, if you look, it actually has, I don't remember if you guys remember talking about this, it has a horizontal asymptote. So it's going to get closer and closer to the x-axis, but no matter what, it's never ever going to cross it. So that's kind of cool. And it just keeps getting steeper and steeper. It's still curved. It's going to start looking like a straight line, especially if you zoom way out. It's going to look like a vertical line, but it never is. It's a curve. Yeah. And then here, let me see if I can find for you guys that curve. Since we're here, let me see. This is a really cool website. It shows you everything that's going on in the whole world. It's not very good on your phone, at least this one with the map and everything. But it shows you the density, so you can like click on an area, and so it'll tell you, oh, I just happened to randomly click on Italy. It'll show you what's going on there. So you can go to all of these different places around the world, and you can click on an area and see what's going on. So this is like a city in Florida instead of like the whole state. But here's the thing I wanted to show you guys. Let's see if I can get this to work. Let me see. The curve. Look at that curve. This is like a zoomed in version, but you see how it's kind of barely growing, and now it's starting to bend and start to turn up. That's interesting because now there's other factors, right? There's other factors here, but let me see if I can get this to look at that. There are other factors, barely growing, starting to go up, but look what happens as you go over time. If nothing happens, it just takes off. Now eventually it'll stop because people will become immune to it and all that kind of stuff, but all right. So anyway, are we good with types of functions and how to identify them? If not, speak up now or forever hold your peace. Let me get caught up on our log over here. So Martin says he needs the TP, but he doesn't say if he's really out or not. And then come up kids like focus data. That's true. That's probably a good idea. So Mariana has a question. And so does Vanya. Let's get to Mariana's question first. She says, so the video that you posted about the penny and the coronavirus, that graph is exponential. Absolutely. You got it right, sister. 100% exponential. And then, in fact, the graph that the doubling penny was this equation right here. 2 to the power of, it's this one right here, 2 to the power of x minus 1. That was the doubling penny. Because on day 1, when x is 1, you had this, 2 to the power of 0, which is equal to 1. Do you see? And then, like on the 31st day, you had 2 to the power of 30. And we can use our handy-dandy calculator right here. 2 to the power of 30, big frickin' number, right? So if this is pennies, the decimal would be right there. It's $10,737,418.24. So that's absolutely right, Mariana. Now, Vanya's got a question. So let's say you only have an output for an exponential function. How are you supposed to figure out x? Well, Vanya, you don't know yet, unless you have a clue. So that would involve these things called logarithms and all that kind of stuff. And that's one of my favorite things to teach in math, but it's not something we learn in 9th and 10th grade. It's usually 11th or 12th grade where you start to learn about logarithms. So the answer to your question is, there is a way. It's really not even all that complicated. It's something called logarithms, and we didn't learn them. But you will, and they're not too bad. They're kind of fun. All right. So, next up, function arithmetic. That's really, really easy. Function arithmetic, add, subtract, multiply, or divide. I don't think you guys are going to have any trouble there. Let's just make sure that we're good with the notation. So if we had a function like x squared minus 4, and we had another function like, let's say 3x. Let's make them kind of easy, right? So adding could be written like this. And there you would just add them, right? So the answer to this one would be, well, that would be x squared minus 4x plus 3x, right? And so you would just put it in descending order. So you'd have x squared plus 3x minus 4. Descending order, done, boom, you're good, right? They could be written like this as well. Same exact meaning, right? Subtraction is, of course, more difficult because if it was subtraction, there would be a minus sign right here, right? And if you're going to do a minus sign, well, that's going to be minus. And this one's not too bad because there's only one term. But if it was more than one term, then you would definitely have to be careful of that, and you would have to subtract. So that would be subtraction. And this is where you guys are maybe going to get in trouble. So let's talk about this real quick. If it said g minus f, well, the first function that's labeled, that's listed here, goes first. So that's going to be 3x. And the second one goes second, like that. You see, and you need to use the parentheses, otherwise you're going to write a minus 4, and this is really supposed to be a plus 4. So 3x minus x squared plus 4. So if we put that in descending order, negative x squared plus 3x plus 4, and we're done. Yeah. So that's add, that's subtract. Multiply is going to be written like this most of the time, right? And that's where we get into confusion because it won't be written like this in Cambridge. You see how there's no symbol in the middle? And that is going to be composition of functions, which in the United States we use this, that little open circle in the middle, right? And composition of functions means that you take the second function and you make that the input for the first. So like here, for the function f, g is the input. Because whatever's in these parentheses right here is the input, which means that you take whatever's there and you place it right here for the x. So this one would be 3x is g squared minus 4. So this would be 9x squared minus 4. Right? So composition of functions. It's plugging in a function one way and the other. And then there's something about inverse functions that I don't know if we really talked about it or not. But if you take a function and its input and you plug it into each other, you're going to get x as your answer. Either way, you're going to get x as the answer. And that might be new. I don't know if we really talked about that or not. But if not, that's okay. Cambridge doesn't really ask you this, I don't think, but it is something that we were probably going to cover in the near future. We'll see how this is going to work out. This might be, I'm going to put it on my list of inverse functions. Verification. All right, so last one. Okay, last one. All right, it's a lot of information. You guys are doing good? You still with me? I know that man, it's hard to concentrate that long. But that's okay. That's okay. We'll get it. Last one is finding inverse functions. So finding inverse functions, pretty much not too bad. Yeah, Ruben says he thinks we did go over that when you do the composition of inverses, the output is just the x. And Mariana wants to know if f... Oh, so Mariana, this is what it looks like you wrote. Hold on, let me switch. So here, let me switch it over so you guys can see. So Mariana, your question is, are these two the same? And that's what it looks like you wrote. These are not the same. But if this was an open circle, they would be. Do you see? I know you don't have that right there. But, yeah. Oh, wow. Dang. Could you give us any practice based on this lesson is what Martin wants to know. Yeah, absolutely. In fact, I know that the function stuff is kind of a big deal, and so we will definitely be I'll put a whole bunch of notes and some practice stuff in the Google Classroom. I already did so for the sophomores, but Martin, what I'll do is I'll go ahead and I'll put that same information in your classroom, okay? Yeah, you're right. Johnny wants to know, in inverse functions, don't you switch the x and the y? Absolutely, because what an inverse function is it switches the input and the output. And then Mariana wants to know, hold on, I lost her question. The closed circle It's actually not a closed circle, it's just a dot. That means multiplication. So it would be like this, Mariana. And instead of maybe even having a like that, it could kind of be like this. Like these are x's, and this is like a multiplication symbol. You see, that's what that means. Yeah. Okay, so this is where it gets confusing. In the United States, that means multiply. Okay, so in our good old US of A, that means F times G of X. So it's multiply. Right? But in England, what it means composition of functions. And composition is where you plug one into the other. So I know the notation's really, really confusing. It's kind of silly. It used to be a lot worse. They're fixing most of those things. Cambridge is, so because they write regionally, some of the notation is different from one place to another, and so they're doing a pretty good job rewriting the notation so that it fits with how things are done stylistically in different regions. And this is one of the last hang-ups that we have. So hopefully it'll be all right. And Ruben's absolutely right with his answer right there. Okay, so now, last one, inverse. Inverse. So check this out. If f of a equals b, well, the inverse would have those switched, right? So inverse functions switch the input and the output. That's why if you had if you had a function like this and you were asked to find the inverse, what you do is you switch the input and the output. So what you're going to do is you're going to say that x equals 3y plus 5. Because f of x equals y. So that's y. This is y. So to find an inverse, all you got to do is switch the x and y, and then you solve for the new y. So to solve this, you're going to use inverse operations. So we subtract first, and then we divide x minus 5 over 3. That's your inverse function right there. Does that make sense? It can get a little tricky sometimes, especially if you've got like a rational function or something like that. So like, especially if you had two of them, then it can get really tricky. But mostly on Cambridge tests, I've only seen really, really simple ones like this. Where things have gotten tricky is they might give you something like f of x equals 2 to the power of x. And they might say f inverse of x equals, say 64, and they'll say solve for x. And this kind of goes back to Vanya's question earlier. If you have something that's exponential like this, how can you figure out what the input was if you knew the output? Well, you could use logarithms, which are a way to logarithms relate powers of numbers, and where the input is the exponent and the base is just a number, right? But we can actually figure this out right here, because we know that input and output, I'm going to change this number to make it a little smaller, a little easier, just for us, okay? So you might be able to figure this out naturally, but here's the deal. Because input and output are switched, and this is the output for the inverse, that makes it the input for the original function. So f of 8 would be 2 to the power of 8, which is like, I don't know, I forget. Let's just do it on the calculator to be sure. Oh no. 2 to the power of 8 is 256. That's 256. So this, x would be 256 for the inverse function. Yeah, those are tricky. Those come up. Actually, those have been on the Cambridge test, a question like that, every year for the past couple of years. And there are actually homeschooled students that live in our area who their parents sign up for them to take the IGCSE exams. And every once in a while we get an email. The math department will get an email from one of those parents wondering, how can a student solve this if they've not learned logarithms? And it's always just something like that. So the only one we didn't get into today that I had hoped to, but I don't really know how we're going to do it, is reading graphs and finding inverse and doing information like that. So, yeah, I don't really know how to do that over distance learning. You would kind of have to have a graph in hand, and um, that's kind of tough to do. So we might have to skip that for now. There is one of those on your quiz though, but I think you'll be all right. I think when we review the quiz tomorrow, I think we'll be okay. Yeah. So anyway, I want to know how you guys are doing with all this. Are you guys good? You feel confident with functions? And what questions you have. If you watch this later, you can always just email me a question, or you can leave a question like in the comment below, or you can put a question in Google Classroom. Nice thing about Google Classroom is if you do have a question, you put it there. I answer pretty quickly, but there's a lot of students on right now, and so you can get help from each other that way. It's kind of a long review. I didn't think it was going to be that long, but hey, that's quite all right. We got our toilet paper prize. We got our math T-shirt, right? Math AF, and I gotta give these things away. I have a few of them. They're all mediums and smalls. But yeah, so Johnny says he's a little overloaded, but fine. So yeah, Johnny, later when you do the quiz, when you start going over something, you get confused. Just rewatch parts of the video to see if that can help you figure out how to do it and what to handle. Right? What if you post the graphs so we can print them? That could maybe work, but not everybody's got a printer. I'll come up with something though, Ruben. I'll have to come up with a way to do that. I'm not sure exactly how to help you guys with the graph part yet, but we'll figure it out, okay? And any of you guys got other questions or concerns, anything like that? Let me know. Hope all is well. I know this is kind of a strange situation, more than kind of, but I don't know. We'll find our way here pretty soon, right? All right, so well, guess it's about time to sign off. You should do a giveaway for 1,000. I already have 1,000 subscribers. I can't believe it, but I do. Not monetizing anything yet. Now, don't call people dummies, Johnny. Johnny, didn't Vanya help you earlier? Jeez Louise. All right. So anyway, you guys are welcome. And oh, that's true. I still don't have a giveaway for the 1,000 subscribers. Well, I'll do an I'll do an inventory. I'll see what I got. See how many I have, and yeah. Well, we'll figure out what we can do, and it also kind of depends on when we go back to school, right? So we kind of mentioned it earlier today in the other video. I have no idea when we're going back. As of right now, it's still officially April 10th, but who knows if that's going to be it or not. Hope so. I hope so. I hope we go back, and I hope it's not too early. I hope we go back and it's the right decision to make. So we'll just see how it is. Doing great, Miss. Yeah. So Manny Garcia Vega says, "How are you doing, Mr. Brown?" Doing fantastic. Yeah. George wants a shirt. I'm gonna. Oh yeah. See, Johnny? Vanya says she's not going to help you next time. You called her dummy. Man, and what she said wasn't wrong. You and I both just misinterpreted it. All right. I really do miss being in class with you guys. I have a lot of fun with you. I enjoy being in the class with you guys, and you guys are doing fantastic. You've been doing fantastic since day one of your freshman year, and you guys